6G network. Welcome to another edition of the Technology Update. 6G is the sixth-generation mobile system standard currently being developed for wireless communications over cellular data networks in telecommunications. It is the successor, or the next bend in the road, after 5G and will likely be much faster. 8 unique features of 6G. 6G networks may coexist with 5G for a while, and will be a significant improvement over previous generations in several ways. This is because 6G will offer the following differentiated features. Number 1. The use of new spectrum bands. Spectrum is an essential component of radio connections. Every new generation of mobile devices requires a pioneer spectrum to fully leverage the advantages of any further technological advancement. Reframing the current digital cellular spectrum from legacy technologies to the next generation will also be a part of this transformation. The newest pioneer spectrum slabs for 6G are anticipated to be in the mid-band 7 to 20 GHz. This would offer larger capacity via extreme multiple input multiple output, MIMO. Number 2. Very high data transfer speeds. 5G is scheduled to offer a peak data throughput of 20 gigabits per second, and a user experience data rate of 100 megabits per second. However, 6G will deliver a maximum data rate of 1 Tbps. Similarly, it will raise the data rate experienced by the user to 1 gigabit per second. Therefore, the spectral efficiency of 6G will be nearly more than double that of 5G. Higher spectral efficiency will offer many users instantaneous access to modern multimedia services. 3. Ultra-low latency network functions. The latency of 5G will be lowered to just 1 millisecond. Many real-time applications' performance will be enhanced by this ultra-low latency. However, wireless communication technology of the 6th generation will decrease user-experienced latency to less than 0.1 milliseconds. Numerous delay-sensitive real-time applications will have better performance and functionality due to this drastic reduction in latency. Additionally, decreased latency will allow emergency response, remote surgical procedures, and industrial automation. Furthermore, 6G will facilitate the seamless execution of delay-sensitive real-time applications by making the network 100 times more dependable than 5G networks. Number 4. Greater support for machine-to-machine connections. While 5G addresses both human users and Internet of Things use cases, 6G will focus more on M2M connectivity. Today's 4G networks support around 100,000 devices per square kilometer. 5G is significantly more advanced, enabling the connectivity of 1 million devices per square kilometer. With the advent of 6G networks, the target of 10 million linked devices per square kilometer is within reach. All 6G networks will include mobile edge computing, although it must be added to current 5G networks. By the time 6G networks are implemented, edge and core computing will be increasingly assimilated as elements of a unified communication and compute infrastructure framework. Number 5. A focus on energy efficiency. As previously discussed, 6G networks will require stronger radio frequencies to meet the requirement for greater bandwidth. However, one of the challenges is that the foundational chip technology cannot yet function energy efficiently in these frequency ranges. Therefore, optimizing power consumption will be a key focus area for 6G developers. Currently, researchers intend to reduce the energy consumption per bit to lower than 1 nanojoule, 10 to 9 joules. Number 6. Greater network reliability. The 5G-led ultra-reliable low-latency communication service will be further developed and enhanced in 6G. Reliability might be enhanced through simultaneous transmission, numerous wireless hops, device-to-device connectivity. Consequently, 6G will be better than 5G in terms of network penetration and stability. In addition, 6G will optimize M2M interactions by increasing network dependability by greater than 100-fold and decreasing error rates by 10-fold compared to previous generations. Number 7. The rise of new architectures. 5G represents the first solution designed to replace wired connections in corporate and industrial settings. It is deploying services-led architecture in the core foundation and cloud-native deployments, which will be expanded to portions of the Radio Access Network (RAN). It is also anticipated that 6G networks will be implemented in heterogeneous cloud settings, including a combination of private, public, and hybrid clouds with a suitable architecture to support this. Number 8. The use of AI and ML for optimal connectivity. 5G will allow artificial intelligence, AI, and machine learning, ML, technologies to achieve their full potential. Eventually, AI or ML will be implemented in various network components, network levels, and network services. From refining beamforming in the radio tier to planning at the cell site with self-optimizing networks, AI or ML will assist in achieving superior efficiency at reduced computational complexity. 6G developers, such as Nokia Bell Labs, want to adopt a blank slate approach to AI or ML, allowing AI or ML to determine the optimal method of communication between two endpoints. Let's talk about the advantages of 6G networks. 1. Enforces security. Cyber attacks are increasingly focusing on networks of various types. The sheer unpredictability of these attacks necessitates the implementation of robust security solutions. 6G networks will have safeguards against threats like jamming. Privacy concerns must be addressed when creating new mixed reality environments that include digital representations of actual and virtual objects. 2. Supports personalization. OpenRAN is a fresh and evolving technology that 5G utilizes. However, OpenRAN will be a mature technology for 6G. The AI-powered RAN will allow operators of mobile networks to provide users with a bespoke network experience based on real-time user data gathered from multiple sources. The operators may further exploit real-time user data to provide superior services by personalizing quality of experience. 3. Drives the development of wireless sensing technologies. The sampling rate refers to the number of samples obtained from a continuous signal per second to form a digital signal. 6G's frequencies will allow for much faster sample rates than 5G. Additionally, they will provide dramatically increased throughput and data rates. Moreover, the utilization of submillimeter waves and frequency selectivity is expected to accelerate the advancement of wireless sensing technologies. The network will become a repository of situational data by collecting signals reflected from objects and detecting their type, shape, relative position, velocity, and possibly material qualities. Such a sensing method may facilitate the creation of a mirror or digital counterpart of the actual environment. When combined with AI or ML, this information will provide fresh insights into the physical world, thereby rendering the network more intelligent. 4. Inspiring new technology innovations. 6G will benefit society as a whole since new technological innovations will emerge to support it. 6G networks will generate significantly more data when compared to 5G networks, and computation will evolve to ultimately encompass edge and core platform coordination. As a result of these changes, data centers will need to develop. Nanocores are anticipated to develop as a single computing core that combines HPC and AI. It is not necessary for the nanocore to be a tangible network node. Instead, it might consist of a conceptual aggregation of computing resources shared by several networks and systems. 5. Saves costs through reduced software dependency. Software-defined operations are already being used by contemporary networks. Additional 6G components, like the media access control and physical layers, will be virtualized. Currently, PHY and Mac solutions require the deployment of specialized network hardware. Virtualization provided by 6G will lower the cost of networking equipment. Therefore, an immensely dense 6G rollout will become economically feasible. 6. Improves cellular network penetration. Among the many advantages of 6G networks is their vast coverage area. This implies that lesser towers are necessary to cover a given amount of space. This is useful if you want to construct towers where it showers regularly or where trees and vegetation abound. Additionally, 6G is intended to support additional mobile connections beyond 5G. This implies that there will be reduced interference between devices, resulting in improved service. 7. Optimizes indoor network usage. The majority of cellular traffic today is produced indoors, yet cellular networks were never built to properly target indoor coverage. 6G overcomes these obstacles using femtocells, small cell sites, and distributed antenna systems,